Hi students, here we are going to start the electrostatics in the fast track revision series for JEE Main. In the electrostatics, we have these topics. All the topics are there, written there. Charge and its properties, charging, electric field, Coulomb's law, etc. Now, one by one topic we are going to start. Now, first of all, we are going to see what is the scope of the electrostatics branch. Electrostatics is that branch of electrodynamics where we are going to have the study of the effects of charges at rest. Means we are going to understand the effect of the charges, how the charges are behaving when they are seen from the stationary point of view, means when they are at rest. Effect of charges at rest, when they are at rest, how they are producing what are their effects. This is what we are going to see. Now you remember the concept of this chapter are not applicable to other part where the charges are in motion. Now in the entire electrodynamics we have a lot of discussion about the charges, a lot of talk about the charges. So first of all we are taking the properties of the charge. Charge is a very basic fundamental attribute, just like mass. Means we cannot define the charge like mass, we cannot define. It is a scalar quantity. Its SI unit is Coulomb. Other units are electrostatic and EMU unit. Charge is of two types, positive charge and negative charge. Now, positive charge and negative charge doesn't mean that positive charge is greater than negative charge. It is only differentiating two types of charges. This positive charge and negative charge is only a way to distinguish two different types of charges. It doesn't mean, it is not at all comparing the magnitude or something of the two charges. Now we have the charge of an electrically isolated system remains constant. Electrically isolated system means if we have a system which is not in electrical contact with anything, then charge of this particular system will remain constant. Charge of this system cannot be changed. But charge is transferred from one place to other, from one body to another. Let us say two bodies are there and they are kept in the electrical contact. Electrical contact you will understand slowly. Then the transfer of charge will take place from this conductor to this conductor, or vice versa, means from this conductor to this conductor, depending upon their potentials, etc. This particular thing we say charge is transferable. Charge can be transferred from one body to another. Next point, we have the like charges repel each other while the unlike charges attract each other. Two like charges are going to repel each other. Positive charge will repel, negative charge will repel. But the unlike charges, two unlike charges, means positive is going to attract negative and so on. But you remember this statement is valid only for the point charges. Why it is so? Because in the electrostatic induction, if we are having the extended object, then even the unlike objects can even the likely charged objects can attract each other if their charges are very much different from each other. That's why this statement is written. This statement holds good only for point charges, and it is a very, very important statement. You have to take care of it. Now, another thing is charge of an, when we are saying charge is a conserved quantity, charge is a scalar quantity. Actually, what is this? The most basic fundamental particle, what we say it is having the charge is the electron. And we say charge of the electron is equal to minus 1.6 into 10 to the power minus 19. It is the most basic. Smaller than this negative charge is not possible. And smaller than this positive charge is not possible. 1.6 into 10 to the power minus 19 Coulomb. So charge of electron is this much. Charge of proton is this much. Charge on the body is always due to excess or deficiency of electrons. If we are having a body and it is having some protons, matter as a whole is electrically neutral, so it will have the number of protons and number of electrons equal. So but if we are saying it is having some charge, it means either some electrons have been removed or some electrons has been added. charge on the body is always due to excess or deficiency of electrons. We don't say due to the excess or deficiency of protons, because only the electrons can be removed or added in the material. When the number of electrons is greater than number of protons, it is negatively charged, because electron is a negatively charged. It is a small point. Now, charge is a quantized physical quantity. Quantized physical quantity means that physical quantity will be always a multiple of some basic unit. Like if I say number of students in the class, then it will be some integral multiple of integral multiple of something. So same way, charge is quantized physical quantity. Charge is due to excess or deficiency of electrons, and electron carries some charge. So if I have removed 2 electrons from the body, then it is having the deficiency of 2 electronic charge. If I remove the 2000 electron, it is having the deficiency of 2000 electronic charge. So it means charge on any body is plus minus Ne, where E is the electron charge of the electron and N is the integer. So we cannot remove 1.5 electrons. So we are saying charge is quantized and it is going to be plus minus Ne. Now, if the electrons has been removed, it will going to have the positive charge, and if electrons has been added, then it is going to have the negative charge. So charge is a quantized physical quantity, and some very basic question can be framed on the basis of this particular statement. Now, next we have the charge is invariant physical quantity. Means it is independent of the frame of reference. It is independent of the velocity of the charge particle. Means one particular charge particle you see from any frame of reference, it is going to have the same value. Charge is not like the mass in the class relativistic physics. Mass depends upon the velocity. So here it is nothing like that. Charge is invariant. Its value remains same in all inertial frame of reference. Another thing is charge cannot exist without mass, but mass can exist without charge. It means if one body is having the mass, it may or may not have the charge. But if in one body is having the charge, then 100% it is going to have some mass. Now, another thing is when we are saying that a body is having the Q microcoulomb charge or 10 microcoulomb charge, then what is this 10 microcoulomb? Is it the total positive charge, or is it the total negative charge, or it is something else? Then when we are saying the charge is Q microcoulomb, it means we are talking only about the excess charge. What is the meaning of this? Say for example, one body is having N1 protons and N2 electrons. Then if N1 and N2 are not equal, then we'll say the charge is equal to N1 proton, charge of N1 protons and N2 electrons. So charge of the proton and electrons are same. So you can say N1 minus N2 into 1.6 into 10 to the power minus 90. Like that we can say. Now, depending upon the motion of the charge, we have classified this entire electrodynamics in 3 parts. One is the electrical effects, one is the magnetic effect, one is the electromagnetic induction, electromagnetic waves, etc. Stationary charge will always produce only the electrical effects. So if a charge is at rest, then its effect will be purely electrical in nature. When a charge is moving uniformly, its effect will be electrical and magnetic. It will have electromagnetic effect. And when a charge particle is having the accelerated motion, then it is having the electromagnetic effect as well as it will emit electromagnetic radiation. Means it will lose the energy also. So this is all about the properties of charge. Now coming to the continuous charge distribution, many times you people might have seen that we say charge is distributed uniformly, non-uniformly. Now on the one side we are saying charge is discrete because charge is quantized physical quantity. It can have only the plus minus any charge. So on one side we are saying charge is discrete, but on the other side we are saying charge is continuous. So what is the logic here? So if say for example from a small piece of material, say 1 millimeter cube, we have added or removed 10 to the power 15 electrons. So see how much big number it is. So if we are removing this a big number of electrons from this small piece, then we can say from everywhere electrons has been removed. So we cannot say from here one electron removed, from here one electron, not like that. So here we can say entire electron has been removed from everywhere. So in such situation, we can we can ignore the discrete nature of the charge, and we can say charge is continuous. So the basic concept behind the continuous charge distribution is this. Now, just like in the gravitation or in the entire mechanics etc., you have seen the different types of mass density, linear mass density, surface mass density, volume mass density. The same way we are going to have the different types of charge density, linear charge density, surface charge density, volume charge density, etc. There's nothing new in that. So we can skip that part. Or even if we say lambda is the linear charge density, charge per unit length, sigma is the charge per unit area, and the rho is the volume charge density, charge per unit volume. Exactly similar to like we define for mass. Now we are moving to the next part, charging process. Now what is actually charging? Charging means when we are having one body and we want to provide a net charge to this body, this object, then this particular phenomena of providing a net charge to an object is termed as charging. The phenomena of providing a net charge to an object is termed as charging. Now there are various ways, like the photoelectric effect is also there, thermionic emission is also there, various ways, frictional electricity is also there. But in our syllabus here, we have the three important ways to charge the object. One is the charging by rubbing, one is the by frictional electricity, you can say, another is the charging by conduction, and third one is the charging by induction. So one by one we'll discuss. First of all, I am taking the charging by rubbing. In this, what we do, we take two non-conducting objects. These two non-conducting objects we rub against each other like this. Then due to the friction here, they will get heated up. Their internal energy will increase. Because of the increase in internal energy of this, one of the object may transfer some of its electron to the other object. As a result, the object which is losing the electron, this object which is losing the electron will acquire some plus charge. And this particular object which is gaining the electron, this will acquire the negative charge because it is having the excess of electron, and this object A is going to have the deficiency of electrons. So A will acquire the positive charge and B will acquire the negative charge. Now in this you have to remember both the objects must be non-conducting. Both are going to have the equivalent opposite charge, and masses of both the object changes slightly. Mass of A will decrease slightly. Mass of B will increase slightly. By how much amount? Equal to the amount of mass of the electrons which has been transferred from one part to other. Now next method we have the charging by conduction. In this particular method, we require one charged conducting object, conducting body, and another second uncharged conducting body. Now, whichever one we want to charge, that I am calling as B, and this is already charged body I am calling as A. We will keep these two bodies A and B in electrical contact. We keep this A and B in electrical contact. Electrical contact means so that the transfer of charges, transfer of current, flow of current, transfer of charges is possible. So when we have connected them electrically, then transfer of charge takes place. One statement I would like to write here. When two bodies are kept in, two conducting bodies are kept in electrical contact, then transfer of charge takes place from one body to other till both acquires same potential. So what happens when these two bodies are we have kept in the electrical contact, then it is having some potential. It is having zero potential. So transfer of charge will take place from one to other. And when the transfer of charge is taking place, either the electron move from here to here or electron move from here to here. In both the cases, B will acquire some charge. And as soon as the B acquires some charge, and that is the only our purpose, that B must acquire some charge. So the charging of the B has been taken place. This is the way in which we can charge the one conducting object with the help of another conducting object. Remember, here both the objects must be conducting. One must be charged, other must be uncharged. Next method we have the charging by induction. Now this is slightly different from the charging by conduction. In this method, one charged body, and this charged body can be conducting or non-conducting. Conducting or non-conducting. This is charged, say it is positively charged. This will be brought near to an uncharged conducting body. Now, if you want to charge one body by this means, by induction, then it must be conducting. We'll place near to it. Then what happens? Because of this, some redistribution of electrons takes place. Redistribution of charge within B. I am calling it as B. Within B takes place. Why it takes place? Because of the electrostatic induction, because of the electrical effects of this charged body. It will create some electric field in its surrounding region like this. And in that particular electric field, some electrons will move like this. So redistribution of charge takes place. This phenomena of redistribution of charge in this particular body, this we call the electrostatic induction. This redistribution of charge within the body, we call this phenomena as electrostatic induction. You see, up till now no net charge has been given to B. The net charge on B is still 0. Only the redistribution has taken place. Net charge on B is still 0. This particular phenomena is temporary phenomena. Why we are calling it as temporary phenomena? Let us say I moved this particular body, taken away. This particular body removed. Then this redistribution, what has been happened, that will disappear. That's why it is going to be a temporary phenomena. Right? Now, up till now, charging not over. We have only causes the redistribution of charge. Once this redistribution of charge has been caused, this will be kept here only. This body will be connected to the ground. When it is connected to the ground, then we know this earth is a good conductor of electricity. Earth is a good conductor of electricity, and this is already a conductor. So when two conductors are connected, then what will happen? Transfer of charge takes place till both acquires the same potential. So here in this case, in this particular example, you will understand slowly. Electrons will flow from here to here. Electrons flow from ground to the conductor B. So as a result, B acquires some negative charge this way. This way, B acquires some negative charge. Because of this negative charge, after that what will happen? We'll remove this earthing part. This particular connection has been removed. This is still there. This charged object is still there. Now when we remove it, now it is isolated. It is not connected to ground. And now it acquires the negative charge. Now after that, we'll move away this. We'll remove this charging body also. This body also will remove. And we left with the only this body B, and this acquires a net charge. So in this way, we can do the charging by induction. We'll stop here, here only. We'll meet in the next video.